Let's take a look at systems of nonlinear equations using the intersect method on TI-89. Now this is my website, www.mathheals.com, and if you go here you can find a link for graphing calculators, and here you'll find more YouTube videos. If I click college algebra, then these are all the different topics in college algebra you can do on the calculator or with the help of the calculator. And I'm going through and creating these videos for every model of calculator. Now, if you just need general help on college algebra, if you go to the first link, math class information, they'll probably change that to math lectures. Then you can go into college algebra. And this YouTube video over here, you can watch that to watch a particular topic, like rational equations. I can click this YouTube video and watch a lecture on rational equations. Now, this is the same lecture, examples, explanation that I give in the classroom. Okay, now let's go back and we want to find our first one here. Okay, so y equals x squared minus 2 and y equals 3x minus 4. Now this method works out nice if you can get y by itself. These are already by themselves, so it works out really nice then. Okay, I want to go into y equals, so I do diamond F1, or I can press apps and go to the y equals editor. And y1, I'll press clear to clear out wherever's there. Then we'll do x squared, so x caret 2 minus 2. Press enter. Now I'm on y2, so I'll put 3x minus 4. So 3x minus 4, and press enter. Okay, now we want to graph this. So I'll do diamond F3 to go into the graph. There's our first one, and there's our second one. Our answer is where they intersect, but I really can't see what's going on here. So I want to choose zoom. You see up here it says F2 zoom, so I do F2. And I want to choose zoom box the first one, so I'll go ahead and press enter on it. Now it's wanting us to put our cursor in the upper left-hand corner of our box. So I'm going to go up a little bit. There, right there, and to the left. And that's probably good right there. I'll press enter one time, and it'll say second corner. Now I'm going to do my down arrow, and I hold down on it. Then I'll do my right arrow until I get the box around the part that I want. And that looks good. And then I press enter. So there's our first graph. And there's our second graph. So it intersects right here where my cursor is, and it intersects right here where my cursor is. So we got two answers to find. Okay, so you see the math here, F5. So I'll press F5. Now bring up this math. And we want to choose number 5, intersection. So I do 5. Asks us for first curve, I do enter on first curve. Asks us for second curve, I do enter on second curve. Asks us for lower bound. Now I want to do a left arrow and move my cursor to the left of where I think the intersection is. Intersection somewhere right here, so that's the left of it. Maybe one more to go a little bit further. And then press enter. And asks us for upper bound. Now I want to move my cursor to the right of where the intersection is in terms of my x values. And that's the right of it. And I press enter. And that tells us our first answer is 1, negative 1. Well, we have another place where it's intersecting, so we have to go through the process again. So I'll do F5 for math, choose 5 for intersection, enter on first curve, enter on second curve, and I'll do my right arrow key. I want to get a little bit closer because I think my intersection is right here, and I want it to the left of it, and that's fine there. I don't want it to be too far away. Press enter, and asks us for upper bound. And now do my right arrow key and move it to the right of where I think the intersection is. So that's to the right of it, and then press enter. And that tells us 2, 2. Okay, let's look at our second problem. We got y is equal to x squared minus 2, and y is equal to negative x squared plus 4. Okay. Now I'm going to set my zoom back to normal. So I press F2 for zoom, and I'm going to choose zoom standard 6. And that sets back to my standard viewing window. Let's go put these in. So I'm going to go to my y equals. So I do diamond F1. up arrow to y2, press clear. Up arrow to y1, press clear. And we're going to have x squared, so I do x key caret 2 minus 2, enter. And then on y2, we're going to have negative x squared, so negative x key caret 2 plus 4, and press enter. Okay, now let's graph this. So we're going to do diamond F3 for the graph. There's our first one, and there's our second one. And where they intersect is going to be our answer. So we're going to have two answers. So I'm going to do my F5 for math. Choose 5 for intersection, the number in front of it. Enter our first curve, enter our second curve. In the lower bound, I want to move my cursor to the left of where I think the intersection is. Here's the intersection in terms of the x values. This is the left of it. So I'll do enter. Upper bound, I'm going to do my right arrow until it's to the right of where the intersection is. And that looks good. So we'll do enter. And that's going to give us negative 1.73. And I think it was 1. Let me see. And 1. Now specifically, look at the variables next to it, xc and yc. So this is stored in xc, and this is stored in yc. If at all possible, we want to convert those to fractions. Well, I can exit out here. So if I do second escape to quit, then I can type in xc. And C, if I do alpha, where's C at? C is the close parentheses. Then you see I got XC, and I can press enter. Now, by doing that, if my calculator is set up to be in fraction form, it should automatically have been there. So it doesn't change to a fraction. Well, that's not good. I wanted to change to a fraction. But let's go back to our graph. So I do diamond F3. And we also got an answer over here. So we're going to do our intersection again. So I'll do F5. Choose 5 for intersection. Enter our first curve, enter our second curve, lower bound. I'm going to do a right arrow to move this closer to it. It doesn't have to be right on top of it, but we want it to the left of where we think the intersection is in terms of our x values. So it's to the left of it. Now lower and upper doesn't mean above and below, so don't get that idea. Now press enter. Asks us for upper bound, so I'm going to move my cursor to the right of where we think the intersection is. And that's to the right of it in terms of the x values. And then I'll press enter. And that gives us 1.73 and 1. We could try to change that to a fraction, but we'll find it doesn't change. So that's as good as it's going to get using the intersect method. Now there are ways on a TI-89 to get the exact value, but I'm steering away from the cast menu as much as possible. The reason why these won't change, let's take a look at that. If I was doing this by hand, I have y is equal to x squared minus 2. And y is equal to negative x squared plus 4. If we solve this by substitution, we pick one of our equations, doesn't matter which one, I'll pick my first one. And we want to solve it for one of the variables. Well, this is already solved for y, so that's done. Now our second step, we would now want to plug this into our other equation. So we got y is equal to negative x squared plus 4. Now right on our first step here, we said y is equal to x squared minus 2. So I'm going to replace the y here with x squared minus 2. And then we want to solve it. Well, I want to get all the x squareds on one side, so I'll take that over to the right side. And take this 4 over to the left side. Remember, you take anything across your equals, your sign changes. The 4 becomes a negative 4. The x squared becomes a negative x squared. Negative 2, negative 4 is negative 6. Negative x squared is negative 2x squared. I want to get the x squared by itself, so I divide both sides by negative 2. And we get 3 is equal to x squared. Okay, now our square root property. Square root property says if you got something squared equal to the other side, you can drop your squared. And you can put a plus or minus square root around the other side. And those are our x values. Now the reason that why these would not change to a fraction is they're not really a fraction answer. They're a radical answer. Okay, step 3. We want to take the answers we just found. X is equal to negative square root of 3, and x is equal to positive square root of 3. And we want to plug it into the equation from step 1. So we got y is equal to x squared minus 2. And we'll plug that in. So we got y is equal to negative square root of 3 squared minus 2. Now when you square a negative, it becomes positive, and a square root and a second power cancel each other out. So you got 3 minus 2, or y is equal to 1. So this answer would be negative square root of 3 comma 1. Now this one here, plug it into, again, our equation from step 1. We're going to plug in the square root of 3. So we're going to have the square root of 3 squared minus 2. Again, the square root and the second power cancel, gives us 3 minus 2, or gives us 1. So this answer is square root of 3 comma 1. And those will be our two answers by hand, and we get the exact value. So if you get decimal and you're happy with that, that's fine. If you need exact values, then you may have to do it by hand. Now, I solved it in this manner because these both had the same powers. But if they did not have the same powers, then our first step would be to solve the equation with the smallest powers for one of the variables. So I just wanted to point that out just in case you have a different problem. Now this is solving nonlinear systems equations on a TI-89 calculator.